In this lesson, we'll explore a more complex set of conditions. Say, for example, we wanted to create a grading system that converts a student's test score out of 100 marks into a letter grade. First, let's define our grading system. Let's say that any mark under 50 is an F. 50 to 59 is a D. 60 to 69 is a C. 70 to 79 is a B. 80 to 89 is an A. And anything over or equal to 90 is an A+. Now we can start creating our if statements. We start with if and create our first condition. If variable x is less than 50, then output an F. Next, you'll see a series of else-if statements. An else-if statement is used if there are more than 2 conditions. In this case, there are 6 conditions. The second condition states that if x is greater than or equal to 50 and if x is less than 60, output a D. Next, if x is greater than or equal to 60 and x is less than 70, output a C. If x is greater than or equal to 70 and x is less than 80, output a B. And if x is greater than or equal to 80 and x is less than 90, output an A. We finish with an else statement, which basically instructs our script to put an A+ in any other scenario. Since the test was out of 100 and the student couldn't get negative marks, the only other scenario can be that the mark was equal to or greater than 90, in which case we've instructed the script to output an A+. So we've set the value of x to 90, and you can see in our web browser we get an output of A+. We can test it with other values just to make sure the script is working. Let's go ahead and test 65. 65 is greater than or equal to 60, and it's less than 70. So if our script is working, we should get a C. Let's go less than 50. Less than 50, and we output an F. So it looks like our script is working. The switch statement compares the value of an expression against a set of predefined conditions, also referred to as cases. If there's a match, the block of code associated with that case is executed. In this example, we have a variable with the value Volvo assigned to it. Next, we've created a switch statement pertaining to the car variable with 4 cases. In the case that the car variable is equal to Volvo, we'll output the text, "You drive a Volvo." In the second case, if the variable value is BMW, we'll output the text, "You drive a BMW." And in the third case, if the car variable's value is Honda, we'll output the text, "You drive a Honda." We then use the default statement to output the text, "You don't drive," if the car variable does not equal any of the cases defined above. So as you can see, it's relatively straightforward. Since our car variable is set to Volvo, in our web browser, we can expect the statement, "You drive a Volvo," to be outputted. If we change this to BMW, you can see that the statement now changes to "You drive a BMW." Now, what if we put something completely unrelated? We'll change the car variable to the value Merc. You can see that since Merc is in none of the cases, it results to the default, which is the statement "You don't drive." Loops allow us to run the same block of code multiple times automatically. In PHP, we have 4 different types of loop statements: the while loop, the do-while loop, the for loop, and the for each loop. Let's start with an example of the while loop. In this example, we have a variable x with its value set to 1. We've then created a while loop that will loop over and over again as long as the value of x is less than 10. Using a post-increment operator inside a while loop, we can keep incrementing the value of x until it reaches its maximum limit in this situation, which is 9. Since x is initially set to 1, the first time the loop runs, the value of x will be 1. The second time it runs, it will increment to 2. It will continue to increment until it reaches a value less than 10, so 9. We can see this in our web browser. We can see that the loop runs over and over again, and each time it outputs the statement, the number is, and then the value of the loop at that instant. If we change 10 to 20, we'll see that the loop now runs 19 times. If we change the value of x to 5, we can see that x will start incrementing at 5. We'll change the value here back to 10. But now what if we change the value of x to a value greater than 10, say 11? We can see in our web browser that there is now no output. The while loop checks to make sure a specified condition is true first before executing the loop. So it checks to see if x is less than 10 first, and if it is, it will go ahead with the loop. If not, it will not execute the loop. Now let's take a look at the do-while loop. This type of loop is different in that it will execute a block of code once, and then it will check to see if a condition is true. From that point, it will repeat the loop only if the condition is true. In this example, we have a variable x set to the value of 6. Next, we've created our do-while loop. We specified the action, which is to echo the value of x, and once the value is outputted, we then have an increment operator that increases the value of x by 1. After the increment operator, we have our while statement and then the condition. The condition states that this loop should only be repeated if x is less than or equal to 5. In this case, it's not, so the loop will not run again, since x is actually equal to 6. Now we can see in our web browser that the loop did execute once, but there will be no further output because the loop will not run again. If we were to reduce the value of x to say 2, now the while loop will run because the value of x is less than or equal to 5. So it'll continue to run until that condition is no longer met. And that is the difference between a while loop and a do-while loop. In this lesson, we'll explore the for and for each loop. The for loop is used when you know in advance how many times you want the code block to execute. The syntax of the Php4 loop consists of 3 parameters, as displayed in the dialog box. In this example, we've created a for loop to output the value of variable x starting from 0 and up to a value equal to or less than 10. In our web browser, we can see the output 0 right up to 10. The for each loop works only on arrays. It's used to loop through each key or value pair in an array. In this example, we've created an array variable, cars, and assigned it 4 values: Volvo, BMW, Honda, and Ford. We then set up a for each loop to loop through each value in the cars array and output the result using the echo statement. We can see in the web browser that each value in the array has been outputted: Volvo, BMW, Honda, and Ford. We can see that for every loop iteration, the value of the current array element is assigned to the variable value. PHP comes with many built-in functions. In addition to these predefined functions, we can also create our own custom functions. A function is a block of statements that can be called upon whenever they're required. A function will not execute unless we specifically call the function in our script. The syntax for a function starts with the word function, followed by the function name. We can place the function statements inside the open and close curly braces. The function name can start with a letter or an underscore, but not a number. Function names are not case sensitive. In this example, we've created a function called displayText. The function has one statement, an echo statement that will display the text my first function. To call the function, we simply write the function name followed by parenthesis and a semicolon, as shown here. We can see the final output in our web browser. The text my first function is displayed. Our second example shows how we can use functions to pass information through arguments. An argument is just like a variable. Arguments need to be specified inside the parenthesis after the function name. We can assign as many arguments as needed, but each must be separated by a comma. In this example, we've created a function named myCar with one argument, car. The function has one statement, an echo statement that outputs the value of the argument car. The value of the argument is derived when we call the function. After the function name, we pass along a value to the argument. Here, we've called the function 3 times, each time with a different value assigned to the variable car: Volvo, BMW, and Honda. We can see the corresponding output in our web browser each time the function executes. We can easily add a second argument to our function. Just place a comma after our first argument and create the second. We'll call this one color. Remember that we'll have to modify our echo statement to output the value assigned to color. The values will come from when the function is called. So we'll create values to assign to our new argument. Now I'll save the file and refresh the page, and we can see that the second argument values are now displayed. We can set default parameters for arguments as shown in this example. Here, we have a function called myAge. We have a single argument assigned to this function called minAge, with a default parameter set to equal 30. Now, when we call this function, if we do not assign a specific value to our minAge argument, the output will be the default parameter value 30. We can see in the remaining calls a value has been assigned. For this reason, the assigned value will be outputted in our web browser. And we can see the end result here. The first call to our function myAge outputs the default value 30. In all the other calls, the assigned value is outputted. In this next example, we've used the return statement to calculate the sum of two arguments, x and y. We can see the arithmetic operation z is equal to x plus y, then a request to output the result using the return method. We can see here that we've assigned values to x and y in our calls to the function named add. The first assignment is 1 for the x value and 2 for the y value. The output is 3. And for the second, it's 3 and 4, so we have an output of 7. And the last is 5 plus 5, which is 10. In this lecture, we'll explore Php arrays. We've already had a bit of exposure to arrays in some of the previous lessons. An array is a variable that can store multiple values. In PHP, there are 3 types of arrays: indexed arrays, associative arrays, and multi-dimensional arrays. We'll start with an example of an indexed array. Here, we have a variable named colors. The variable contains 3 values: blue, green, and red. We can output each value in the array by specifying its unique index number in square brackets, as seen here. We have an echo statement, and then just some text, my favorite colors are, and then each value in the array is referenced using its index number in square brackets. An index always starts with the number 0. So the 0 in this case is assigned to the first value in the array. Blue would have the index number 0. The index number increments by 1, so the value green would have the index number of 1. And red would have the value, or the index number, of 2. We can see the output in our web browser here. We can use the count function to return the length of the number of values in an array. In this case, we have 3 values: blue, green, and red. By typing count and then the variable name, colors, we can see that 3 is outputted in our web browser. We can loop through the values of an indexed array using the for loop. First, we specify we want the value of x to start at 0 and increment by 1 up to the length of the array. And the length of the array is obtained using our count function and storing the value in a variable called rLength. And so we can see that variable here as well. Next, we simply loop through each index number in our array, which will output the value attached to the index number. And that's done here. Echo, colors, and then the index number. And we can see the output here in our web browser. The next type of array we want to explore is the associative array. This type of an array allows us to assign values to our elements, and this is referred to as named keys. In this example, we've created an associative array variable named tscore. For the purpose of this example, we'll assume tscore holds the mark that students scored on a test out of 100. Tscore has three elements, John, Bill, and Dan. Each element has a named key, or value, assigned to it. So John is assigned 60, Bill is assigned 80, and Dan is assigned 75. Next, we use our echo statement to output the mark that Bill got on the test. We do that using our echo statement and inserting the named key in square brackets next to the associative array name, as seen here. And in our web browser, we can see the corresponding output. Bill scored 80 out of 100. We can loop through an associative array using the for each loop. And we've gone over the for each loop before, so we can see the output displayed in our web browser, but this time with the named key value as well. In the last tutorial, we explored the associative array using a single named key. In this lesson, we'll create an array that holds multiple key value pairs, known as a multi-dimensional array. A multi-dimensional array is an array that contains one or more arrays. First, let's look at the following table. Here, we have a student's name followed by the grades each student has received on 2 tests. In our example, we've stored the data in each row in an array. The first array has the name John and his 2 test scores, followed by Bob, Sam, and Ted. We have 4 arrays in total. Each array's values can be accessed using its position in the table we looked at earlier. The value is actually its index number, but the table makes things much easier to understand. Taking a look at our first echo statement, we can see that the value John in array 1 has an index number of 0, 0. John's first test score has an index number of 0, 1. His second test score has an index number of 0, 2. Now let's output Bob and his 2 test scores. Bob has an index number of 1, 0. His first grade can be referenced using index number 1, 1, and his second test score, 1, 2. Sam has an index number of 2, 0. Test 1 is 2, 1, and test 2 is 2, 2. So by now you can probably see the pattern, and you can apply the same concept to output Ted's grades as well. PHP offers different methods of sorting the elements in an array. We'll start with the sort function. In this example, we have an array called names with 8 values: John, Bob, Dana, Sue, and so on. To sort each value in the array alphabetically, we can use the sort function. To do so, we type sort and the name of the array in parentheses. Next, we can use a for loop to output each value in the array. You can see the output in our web browser, and each value is sorted alphabetically. Note that this sort function works for numerical values as well, and we can use the rsort function to reverse sort the values. So simply replace sort with rsort, save the file and refresh. And now you can see the order has been reversed. We can sort the elements in an associative array. in ascending order by their value using the asort function. So here we have an associative array named tscore. Inside this array, we have 3 keys and 3 values. John, Bill, and Dan being the keys, and the values being 60, 80, and 75. To sort them in ascending order, type asort, and then the name of the array in parentheses. Next, use a for each loop to output each element in the array. And you can see in our web browser that we've sorted it by the value and not the key. We can sort by key rather than value by using the ksort function. And now we've sorted by key. To sort according to value in descending order, use arsort. So again, this is to sort according to value in descending order. So now we have 80, 75, and 60. To sort according to key in descending order, use krsort. And now you can see we have John, Dan, and Bill. Superglobals are variables that are built into PHP and that are always available for use. You might recall that we worked with one such variable called globals. In this example, we have a global variable z that stores the sum of variables x and y, x plus y. X is equal to 30 and y is equal to 40. We can see the global variable is accessible from outside the function, even though it was defined inside the function. So here we have echo z, and that outputs the result, which is 70. Remember, normally when a variable is declared inside a function, it's considered a local variable and cannot be accessed outside the function. So we can see that the globals variable is an exception to that rule. There's actually quite a number of built-in global variables, and it would take quite some time to go over each one. For this reason, we've provided a couple of examples in this lesson and included the remainder in your downloads folder. The first here we have the PHP server superglobal, and this variable stores information about headers, paths, and script locations. We can see the output in our web browser here using the echo statement. The server name superglobal returns the name of the host server. Since this script is hosted on my local machine, we see the word localhost displayed in our browser. Other commonly used superglobals include request, post, and get. We will be working with these in the lessons to follow. To process HTML form data using PHP. The concepts explored here are very important because web pages interact with users using forms. Form data can be used for many things. We can insert data into a database. We can email form data to our users, such as a confirmation email or a thank you note. We can also use form data to perform arithmetic, or perhaps a combination of any of these purposes. Form processing starts as soon as we fill out an HTML form and click the Submit button. At this stage in the course, you should be familiar with creating HTML forms. We know that the form element has an action attribute. In our HTML course, we did just about everything except assign a value to our action attribute. It's the action that brings our form to life. The action of our form will point to a PHP script. In addition to instructing our server on what to do with the form data, the PHP script can also validate the form. This means we can check things like email addresses or phone numbers to make sure they're in the right format. We can also check to make sure that form inputs are not left empty or put limits on how much data can be inputted. These are just a few examples. PHP form validation is done on the server, meaning it's the most effective form validation available. We did some JavaScript validation in the JavaScript course, but we also pointed out that JavaScript can be turned off by the user because it's a client-side programming language, not a server-side. PHP validation cannot be turned off, making it the safest way to test form inputs for data accuracy. We'll be exploring two ways to transmit data to our PHP script from our HTML form: the get method and the post method. In both methods, the data is transmitted in an array that is automatically generated. The array holds the key and value pairs. The keys are the name of the form controls, and the value is the data inputted by the user. We'll come back to this when we start creating our form. There are some important points to note about post versus get before we begin. The get method passes our array variables through the URL parameter. The get method should only be used for sending non-sensitive data. Never send passwords through the get method. All variables are displayed openly in the URL. The get method has limits on how much information can be sent. The current limit is 2,000 characters. Now the post method passes variables using the HTTP post method. The post method is much more secure because variables are not displayed in the URL. Information that is passed is invisible to others because it's embedded within the body of the HTTP request. It has no limits as to the amount of information we can send. And this method is preferred by developers. Both inputs have a name attribute. The first input's name attribute is set to fname. The second is set to email. Our form action is set to send.php using the post method. Now, if you're following along with this tutorial, you'll need to create a file called send.php and save it in the same directory as your HTML form page. So I've saved my page that contains this form as forms.php. I also have a send.php file, and I've saved it in both files in the same directory. Remember, we're saving these files in the folder called PHP lessons. Now in the send.php file, we have a first name and email text label. Next to each label, we have an echo statement that outputs the information the user filled into the form. To do this, we use an echo statement with a super global post variable that contains the information typed into each input. So remember that we use the post method to send the data to this send.php script. So that post data is stored in the super global variable post. One other important thing to point out here is in our square brackets, we have the same name that was used in our name attribute corresponding to each input. So the first name input we called fname, and the second we called email. So it's very important to make sure that that is identical inside the square brackets in your super global post variable. It is case sensitive and it must be an exact match. Otherwise, your data will not be sent to the send.php file properly. So just make sure that it's identical. Okay, so now let's test out this file. So open the forms.php file in your web browser using the localhost URL. Okay, and the page should look like this with two inputs. Now just type some information into the inputs and click submit. You should see the data outputted on the send.php page. And so that tells you that you've done everything correctly. You'll notice that the transmission of the data from the form to the PHP file was invisible to the user. Now let's try the get method. We'll change our send method to get. And just make sure you save the file after you make the change. Now go to your send.php file and also update the super global post variable to get. And save. Now in my web browser, I'm just going to go back and refresh the form page and plug in some different information. Press submit again. So we can see that the output is the same, meaning it's the first name we put in and the email we inputted. So the functionality is identical, but if you take a look at the URL, you can see the variables and the values all in plain sight. So fname is equal to Dan and email is equal to Dan at gmail.com. So right there, you can see why the get method is quite insecure, especially if, for example, the user is entering a password they'd like to use on your system. Then the password will also be transmitted in the URL in plain sight. So for any kind of sensitive information, if your form is dealing with any kind of personal sensitive information, stay away from the get method and stick to the post method. Script that outputs data a user has inputted into a form on the same page as the form. The PHP script will also do some basic validation that will program into a function. We'll do the following to all inputted data. We'll pass variables through PHP's HTML special characters function to make sure data is transmitted securely. We'll use the trim function to strip any unnecessary characters such as extra space, tabs, or breaks inserted into the input fields. We'll use the strip lashes function to remove any backslashes from user inputted data. This helps add an additional layer of security and protects data integrity. Before we get started, I'll show you a demonstration of the end result. You'll notice right now, under the heading user input, there's no information next to the field labels. When I press submit, we can see that the data that was inputted into the form has now been outputted on the same page next to these text labels. Since the PHP variables are sent to the same page as the form, we'll need to use the post method coupled with our form action set to the super global variable server. We'll get to that in just a second. So let's go ahead and get started. The file used in this lecture is available in the Downloads folder. The HTML you see here is just a basic table that contains all our form elements. So right now, there's no PHP in the script. You can take a moment to go through it. It's just a form, and inside the form there's a table, and it contains all of our form labels, our inputs, and our buttons. We've already named each input, so we can see here, next to the text label name, we have the name input. And this input has the name attribute set to name. Next, we have website. And website, this input has its name attribute set to website, followed by position, experience. Now, employment status, we've set it to e-status, just to be more efficient. Comments, the name is set to comments. And then we have our two buttons. The first thing we'll do is create our form action. So what you're going to do is you're going to type the following into the action attribute in your form element. Okay, so it's a little bit long. The global variable server will send the submitted data to the same file as the existing file. We've embedded the global variable server in an HTML special characters function. And this provides an additional layer of security by preventing anyone from injecting malicious JavaScript code into the transmitted data. So it's important to include that. And you'll see that the global server variable is set to PHP self. So this is what allows us to transmit this data to the same page that we're working on. And that's going to output the information on the same page as well. Our method is already set to post, so we don't have to worry about that. So let's go ahead and start with our PHP script. So create your PHP tags. We'll need to define the variables that we'll use to contain the inputted form data. So enter the following variables. And we're going to set each one of these variables to an empty value for now. And you'll see that the variable names we've used are the same names as the names that we've given our input fields. Now we'll have to create a function to validate the inputted data. And so you're going to go ahead and create this function. Okay, so we've called this function val, and this function has one argument called data. There's three statements in this function. The first statement will trim the data, so it'll remove any unnecessary spaces, and then it'll remove any unnecessary backslashes using strip lashes. And we're securing the data by using the HTML special characters function as well. So these are the three basic ways we'll be validating the data. So next we'll create an if statement that checks whether the user has submitted the form. And we'll do this using the server request method you'll see in a second. Okay, so you're going to go ahead and type in the following block of code. So you can see that we've set the global server variable here to request method, which equals post. And what this does is it checks to see if any data has been posted. And the only way data would have been posted is if somebody had clicked the submit button. Now, if the data has been posted, then we've created a series of variables. You remember we defined these variables up here and we set it to an empty value. Well, if the form has been submitted, these variables will now take on new values. So the name variable will take the value in the name field. The website variable will take the information and put it into the website field, and so on. And you can see that all this data will be retrieved using the post super global variable. Now that information will be stored in our new variable. We've also enclosed our post super global variable in the function that we created, the val function. And so each variable is going to be validated using the 3 validation techniques we'd specified in the function. The last thing we need to do is just create the output, and we'll do that using the PHP echo statements. This was the demo file. I'm just going to switch now to this new file that we're working with. So enter this block of code underneath your form, your closing form tag. And this is fairly straightforward. It's just a series of echo statements that is going to output the information that the user is inputted. So once you've entered that block, save your file and refresh your page. And just test to see if it works. Okay, it looks like it's working fine. So we can see that all the data that was inputted into the form has now been outputted on the same page. In the next lesson, we'll be working with additional types of validation techniques. Font color to red. Now we can create our validation. We need the validation statements to execute as soon as the form is submitted. We also want the data outputted only if the required fields are completed. So remember, this is our output section, and we only want the values outputted if the fields name and website are not empty. So that's the objective here. So first, begin by inserting the following block of code inside your first if statement. So we're nesting one if statement into another. And I'll explain what this means in just a second. I'm just going to format it so it looks a bit cleaner. Okay, so we've inserted an if statement. And before I explain what each statement does, I'm just going to make sure I close this if statement, otherwise the script won't work. So always remember to close all your open if statements. Okay, so we've created our first line here, states that if the first name field is left empty, to echo an error message stating that the first name is required. There's a second condition. If the website field is left empty, then echo another error message stating that the website is required. If both the name and the website field have been filled in by the user, then the code inside the else statement will be executed. And that basically means that the data that the user inputted will be outputted in our web page. Okay, and so that's it. We've added 2 additional validation components to this script. Now let's go ahead and test the file. So I'm purposely going to leave everything empty and press the submit button. So you can see that now none of the information has been outputted because validation has failed and an error has been outputted. The error is that the first name is required. So if we enter our first name, let's see what happens if we press submit. Okay, now it's stating that the website is required. And I'll just change the formatting of this error so it matches the first one. Okay, so now it passed the first test. The first name was inputted, but it failed the second test. The website is required. So if we enter the first name and the website, and then press submit, then validation checks out and all the data is outputted. Okay, and you'll notice that the comments field was left empty, and that's fine because we didn't add any validation onto the comments field. Only the name and website had additional validation. Inputted data. We'll start with the Pragmatch function. We've added a new else if statement to our previous document as shown here. We can use the Pragmatch function to test whether a string meets a specified pattern. In our case, we'll test to make sure that the name only contains letters and whitespace. This will prevent someone from typing in numbers in the first name. We've also added another else if statement using the Pragmatch function again. This time, it checks to make sure the inputted website is in the correct format. For example, www.mywebsite.com would be an acceptable format. So let's test our script out to see the result. We'll start by typing numbers in the first name. So we can see that the error now outputs name can only contain letters. Now we'll type the wrong website format. So we can see the error, website is in the wrong format. And when the name contains only letters and the website is in the correct format, we can see that the submission works and the data is outputted. The important part of web development